Alright, in this video we're going to be talking about how to add and subtract rational expressions. So just like with any fraction, if it's just numerical or if it has variables, you have to have what we call an LCD. So the LCD is the least common denominator. So when we're looking at the least common denominator, especially with expressions, we got to make sure that they all have, what do they have in common, and then what do they need to have in common because of what they have alike. So the least common denominator is the smallest denominator that contains the factors of two or more separate denominators. So when we're looking at this first example, all I want to do is identify the least common denominator. So when I look at the denominators at the bottom, I'm asking myself, what do they have in common and what does each piece have separate? So they have in common x plus 2, so they already have that together. What they don't have in common separately is the x minus 4 and just the x. So the LCD in this problem is going to be x times x plus 2, just one of them because they already have that in common, and the x minus 4. So eventually we're going to need the denominators of both pieces to contain all of those. So same thing for this one. Now in order to do this one, we're going to need to factor first, because we can clearly see that this one has a GCF and this one is a trinomial. Hopefully we can do the slide divide method. So looking at this first one, we can definitely pull out a GCF of x. That's going to leave me with x plus 3. Now for this one, of course I have an a value of 1, so if I try to slide that 1 over, that's not going to change it. So we're just going to do our x chart here. So in our x chart, we want two numbers that multiply to give us 12, but add to give us 7. So the two numbers that are going to work for that are going to be 3 and 4. So we have x plus 3, and we have x plus 4. Now, typically, if we were doing slide divide, we would need to divide by 1 because we slid the 1, but technically that's not going to change anything, so we're done. So for the LCD, they already have x plus 3 in common. So they have that in common, but separately, they have an x and they have an x plus 4. So my LCD for this problem is going to be x times x plus 3 times x plus 4. So we want to make sure that when we're trying to add these that we have a common denominator here. And we don't want to make a denominator that makes us have to simplify more later, so we want the least common denominator. So what steps do we need to take here? So when we're doing our steps, first we're going to determine the LCD, the least common denominator. We're going to multiply each fraction, the top and the bottom, by what's missing from the LCD, and then add or subtract the numerators and put it over the LCD, and then simplify if necessary. Alright, so looking at number 1, first thing I need to do is I need to identify the LCD. Okay, so when I look at these two, so I have 3a and I have 4b. Right now they have nothing in common. So my LCD would be 3a times 4b, which is simply going to be 12ab. That's what we need our denominator to be when we're done. So what we're going to do is we're going to multiply this side by 4b, and we got to multiply it by the top and by the bottom. So when we multiply it by the top, we're going to get 8b plus 12ab plus, and then on this side, we're going to multiply this side by 3a because that's what this side was missing, the top and the bottom, so that we can make 12ab. So again, when we multiply that together, this is going to give us 12a over 12ab. So now, at this point, we have a common denominator, so we should be able to simply add our numerators together. So if we add these together, they're not like terms, so this is going to become 8b plus 12a over 12ab. Now, I can simplify this a little bit further. And I can simplify this by saying, okay, I know these are both divisible by 2, and these are both divisible by 2 as well. So when we're looking at this situation, if we divide this out, we're going to say 8 divided by 12 and 12 divided by 12. So this is going to become 2b over 3ab plus 3a over 3ab. So basically we divided all of it by 2. Alright, so for our next example, we need to figure out how to add these together, and we need to figure out their common denominator. Now, one thing I notice is they do look very similar, but this one is a plus and this one is a minus. So they are not the same. So my LCD is going to be x plus 1 and x minus 1. So when we're done, we want our denominators to be x plus 1, x minus 1. So we're going to multiply this side by x minus 1 on the top and the bottom. And this side we're going to multiply by x plus 1 on the top and on the bottom. Alright, so when we multiply here, we're going to distribute this 3 to the x and to the negative 1. So that's going to become 3x minus 1 over, and I would leave these in the form in which they're already factored because we may need to simplify later. So again, we're going to distribute the 4 to the x and the 4 to the 1. So this is going to be 4x plus 4. And then we have x minus 1, x plus 1. So now what we're going to do is we're going to be able to add our numerators because we now have a common denominator. So we have like terms, so we have 3x and 4x is going to become 7x. And then negative 1 and 4 becomes plus 3. And that's going to be over x minus 1, x plus 1. Now, we always need to check to see if we can simplify the numerator and see if we can simplify any further. But with this one, we have 2 terms. I do not see a GCF, so at this point, this would be my end of my adding for this problem. All right, so looking at the next one, so I see here that I have a denominator of x plus 5 and a denominator of 2n plus 6. Now, I absolutely can go ahead and GCF this and make it a little bit easier to see. In doing so, I can go ahead and simplify this. You can go ahead and simplify or not simplify. It's completely up to you. You will have to simplify at the end though. And what I'm trying to simplify here is I have a 4 and a 2. So if I simplify this, this is going to become 2n over n plus 3. And again, you don't have to simplify it. However, eventually at the end you will if you don't do it now. So my LCD for this problem, my least common denominator, is going to need to be n plus 5 and then n plus 3. So we're going to multiply this side by n plus 3 on the top and the bottom. And we're going to multiply this side by n plus 5 on the top and on the bottom. All right, so again, we're going to distribute that 5. We're going to distribute the 5 to the n and to the 3. So that's going to be 5n plus 15. And then we have n plus 3, n plus 5. All right, and then on this side, we're going to distribute the 2n to the n and to the 5. So that's going to be 2n squared plus 10n. And that's all going to be over n plus 3, n plus 5. All right, so now that we have that common denominator, we can combine our numerators together. We can go ahead and add those. So this is going to become 2n squared. We have like terms of 5n and 15n, or excuse me, 5n and 10n to become 15n plus 15. And that's all going to be over n plus 3, n plus 5. Now, this is a situation where we may or may not be able to simplify, but we definitely need to check to see if we can simplify this and see if any of our factors cancel each other out. So in this situation, we would technically try to simplify this by sliding that 2 to the 15. So that's going to become n squared plus 15n plus 30. So we're going to look to see what multiples of 30 could potentially give us 15. So what two numbers add to give me 30, or multiply to give me 30, but add to give me 15. So I have like 1 and 30. That's not going to work. We have 2 and 15. Then we have 3 and 10. 4 is not going to work. We have 5 and 6. So if we kept going through this, this is never going to work. So this is not factorable, which means that this is my final reduced answer. We can't factor this any further, so we can't reduce it anymore. And that is my new rational expression after we've added it together. Okay. All right, so the next one. So the next one, I actually have 3 pieces, and out of these 3 pieces, I have some addition here. So we're adding these two together, and we're subtracting these two. So what do they have in common? So they have, all of them have an x in common, so we don't have to worry about x. And then I'm looking at 6, 3, and 4. So 6, 3, and 4, the least common number, least common multiple for that is going to be 12. So we can turn all of those numbers into a 12, depending on how we multiply it. So to turn a 6 into a 12, we're going to multiply this by 2 on the top and 2 on the bottom. To turn the 3 into a 12, we're going to multiply 4 on the top and a 4 on the bottom. And for the last one, we have 4, and we're going to multiply that by 3 on the top and 3 on the bottom. So we have 2 over 12x plus 8 over 12x minus 9 over 12x. And then again, we can now add and subtract our numerators. We have the same denominator, so we have 2 plus 8 is 10, minus 9 gives me 1 over 12x. All right, for number 4, we're going to check to see. We have 5x plus 4 and 2x plus 3. So first thing I need to do is just make sure that I can't factor it and reduce it in any way. So I'm looking at the first one. We have 5x plus 4. That can't be reduced. And neither can 2x plus 3. So my LCD is going to have to be a combination of both of them. So we have 5x plus 4, and we have 2x plus 3. So we're going to multiply this side by 2x plus 3 on the top and the bottom. And then on this side, we're going to multiply by 5x plus 4 on the top and the bottom. All right, so we're going to distribute the 2x to 2x and to 3. So that's going to become 4x squared plus 6x. And that's all going to be over the LCD, which is the 2x plus 3 times 5x plus 4. Plus, so we're adding these, and we're going to distribute the 6x to the 5x and the 6x to the 4. So that's going to become 30x squared plus 24x. And that's all going to be over the LCD, which is again the 2x plus 3 and the 5x plus 4. So now that we have a common denominator, we can go ahead and add our numerators. So we do have like terms, which is 34x squared. And then the 6x and the 24x is going to become 30x. And that's all over 2x plus 3. And then 5x plus 4. Now, in the numerator, I can see that they're both even, so and they have an x in common, so I can try to simplify this further. So I can pull out a GCF, so 34 and 30, that's going to have a GCF of 2 and an x. So if we pull that out, 34 divided by 2 is going to be 17x. 30 divided by 2 is going to be 15 with no x's left over. And that's all going to be over 2x plus 3. And then 5x plus 4. Now, I can't reduce this anymore, so that's my final answer. All right, so for number 5, I can see here that in this denominator, I need to try to factor this to see if we have any factors in common for our LCD. So technically, I would have 1 here, and that 1 would have been slid over to the 18, but that's not going to change anything. So we're just going to do an X chart. And in this X chart, we need two numbers that multiply to give me negative 18, but add to give me negative 3. And for those two numbers, so we have 3 and 6, but we need to make the 6 negative. All right, so that's going to be x plus 3, x minus 6. Now, they do have a piece in common, which is the x minus 6. Okay, so we don't need to multiply everything. We just need to multiply this one second piece by the x plus 3 because it already has the x minus 6 in common because my LCD is x plus 3, x minus 6. So we're going to multiply this side by x plus 3 on the top and the bottom. All right. So once I multiply that out, this over here is going to stay the same because it already had the x plus 6 in common, and my LCD, we're going to include the x plus 3. And we are subtracting, so that is very important here. We're subtracting. So we're going to distribute the 5x to the x and the 3. So that's going to be 5x squared plus 15x. And that's all over x plus 3 times x minus 3. X minus 6. Now, when you are subtracting, it is very important that you apply that subtraction. This whole thing is being subtracted, not just that first piece, the whole thing. So what I recommend doing is go ahead and distributing the negative and making that a negative 5x and this a negative 15x, and then just change that to addition. And by doing that, that prevents you from having to, or if you might accidentally forget to subtract the whole thing. So we can now add our numerators together. So if we add our numerators together, that's going to be negative 5x squared. Then we have x and negative 15x, that's going to give me negative 14x plus 2. And that's all going to be over x plus 3, x plus 6. All right, so for these purposes, I do have a negative in front. I could potentially pull out a negative in the front of it so that this would be like negative 1. And then this would be positive 5x squared plus 14x minus 2. So we are going to try to factor this to see if we can get this to reduce. So I would slide that over. And by sliding that over, this is going to turn into negative 10. So we have x squared plus 14x minus 10. So we need two numbers that multiply to give me negative 10, but add to give me 14. So again, my options are going to be 1 and 10 and 2 and 5, which cannot work. So this is not reducible, so that would be my final answer. Now, for number six, I wanted to show you the formatting here because if you notice, this right here is written, it looks the same, but it's actually backwards. And the reason that it's backwards is because this is technically negative x plus 9. So whenever you have a situation like this where technically they're opposite signs, you can always pull out a GCF of negative 1. And that's going to turn that into positive x minus 9, which then gives me a common piece for our LCD. So our LCD for this problem is going to be negative 1 times x minus 9, because they have x minus 9 in common, but that negative 1 is still part of the problem. So the only thing that I need to do is multiply this one by negative 1 in the top and negative 1 in the bottom. So this is going to be 1 over negative 1 times x minus 9 plus negative 1 times 5x is going to be negative 5x over negative 1 times x minus 9. So they now have a common denominator. So I can go ahead and add my numerators together, which they are not like terms. So when I write it, it's going to be negative 5x plus 1 over negative 1 times x minus 9. Now, I would simplify this. They're not going to leave that negative 1 sitting out in the front like that. So what do I mean? I mean, go ahead and divide that negative 1 into the 5x and that negative 1 into the 1. So negative 5 divided by negative 1 is going to become positive 5x. Positive 1 divided by negative 1 is going to be minus 1. And since we divided that out, that's just going to be left over x minus 9.